right, good morning, good afternoon, good evening, whenever you guys are tuning in for this video. In this video, we're going to do some quadratic equation and some quadratic simultaneous equation. So remember what quadratic equations are. These are the equations that have two solutions. So quadratic simultaneous equations is where we're going to be solving for two solutions for x, and we're going to be solving for two solutions for the y. So let's start with the quadratic equations. Let's jump right into it. So let's take something as easy as this. Start off easy and then we'll wake our way up. So this is your quadratic equation and you're asked to solve for x. What you must do is you always want to have it in the standard form. And what does that mean? It means I always want to see it as ax squared plus bx plus c is equal to 0. That's what I know as my standard form. And so if I take the 6 to the other side, it's x squared minus 5x minus 6 all equal to 0. Then once you have it in your standard form, you could do one or two things at this point. You could either use your quadratic formula to solve this, or you could try factorizing it. So the first 4 examples that I'll be doing, they don't require you to do a quadratic formula. They're quite easy to be factorized. So I implore you, I encourage you to actually solve them using your normal factorization methods. So I would open my two brackets and I would factorize that trinomial. Factors of 6 that add to give me a negative 5 is a negative 6 with a positive 1. So those are my factors. All I need to do is take the first bracket, make it equal to 0, or the second bracket and make it equal to 0. What am I applying here? I'm applying this whole idea that if a times b I'm multiplying to give you 0, then either a is 0 or b is equal to 0. So I'm using this law here and you will see me using it a lot. And yeah, you just need to know what that law is and how to apply it. So I just took this guy, which is my a, and I made it equal to 0. And I'm saying, oh, this guy is the one that is equal to 0. And in each of these, I can solve for x easily. So x is equal to 6 in this guy. And in this next one, x is either equal to a negative 1. So these are my two solutions. All right. I hope that makes sense. Let's move on to the next one. The next one, we are given a 2x squared is equal to an 18. Right? Again, we want to see it in standard form. So I'm going to bring the 18 over. It subtracts. It gives me this expression. Right? At this point, I want to first take out the 2, which is a common factor. And so 2 times an x squared would give me back to the top. 2 times a minus 9 would give me back to a minus 18. Right? And then once you have the 2 outside, I'm going to divide both sides by 2 to get rid of the 2 that is in front. And then I'll end up with this binomial. And this binomial, what we know it as, we know that binomial as a difference of 2 squares. What does that mean? It means this guy is a square and this guy is a square, and they're subtracting there. And so since they're subtracting, I could just open easily 2 brackets. And how to factorize this, I just square root the first term. It gives me an x. That x goes into the first position of both brackets. I square root the second term, which is the 9. It gives me a 3. That 3 goes into the second position of both brackets. 1 is negative and 1 is positive. And again, at this point, I'm going to use that law and say x plus 3 is equal to 0, or the x minus 3 is equal to 0. And here, x will be positive 3, and in this case, x will be negative 3. So that's one way of doing that. There is another quick way of doing it, but I prefer this one because to me it makes more logical sense, more mathematical sense to me. There's definitely another way where you could end up with that +3 and -3. All right, let's try another one that we can factorize. What about a 2? Let me use black. What about a 2x squared minus a 9x plus a 10 is equal to 0? How do we go about factorizing this? So here, straight up, it's already in standard form, so we just need to factorize it. So what I need to do with these, if I see that there's no common factor that I can take out, but then the coefficient of x squared is not 1, then what I do is I take the 2 and I times it across. This is just my method of solving this type of trinomial. So a 10 times a 2 would give me a 20, right? And then once I get to this point, I can easily factorize those. Factors of 20 that add to give me a -9. I'm thinking it's a -4 and it's a -5, right? But just as much as I multiplied across with that term, I need to come and divide these factors with that same number that I multiplied across. So in this case, I multiplied across with the 2. I am going to divide the 4 with the 2, and I'm going to divide the 5 with the same 2, right? Remember, once we multiplied across, we actually changed the value of that expression, so we need to come back and kind of set things straight, right? And if you do that, the first bracket kind of simplifies into a 2 because a 4 divided by 2 is a 2. The second bracket does not simplify. So the ones that do not simplify, you leave it like that. And so at this point, you could just take each one. You take your x minus 2, you make it equal to 0. You take your x minus 5 over 2, you make it equal to 0. So x is 5 over 2, one of my solutions, or x is equal to 2, one of my other solutions. So another question that pops up a lot is, do I need to write this or every single time between my values? No, not really. We're not really pedantic on the fact that you know that it's either one of those options that would work, not both of them at the same time. But yeah, you can write it if you want to. You can leave it out if you don't want to. If you don't want to write it, it's also fine. You'll still get your full marks there. All right, let's do one more where you kind of need to factorize it. So we're given this guy and we're given this guy in brackets, and they're all multiplying to give you a -16. So in this case, it would never make sense to take this bracket and make it equal to -16 and take this bracket and make it equal to -16. No. That rule of A times B is equal to 0 only works if they multiply and they're equal to 0. We can only use it if our answer is equal to 0. So in this case, it's not equal to 0. So what do? I need to expand that bracket first. So expanding it will be x times x is a x squared. X times a +2 is a +2x. -8 with a x is a -8x, and a -8 with a +2 is a -16. So I would need to first expand those brackets, and then I would gather my like terms, every single thing on one side. But while I'm gathering, let me just evaluate this. A 2 minus an 8 is just a -6x, and you end up with a -16 plus a 16. Where is this plus 16 coming from? It's this -16 that went over my equal to sign. So at this point, these cancel, and I'm left with an x squared minus 6x is equal to 0. This, again, you can factorize quite easily. You take out your common factor, which is x. you're left with an x minus 6 in your bracket. And what does this mean? It means x is either equal to 0, this first guy there is the a, or x minus 6 is the one that's equal to 0. And in this case, x is equal to a positive 6. So these are my two solutions, which is 0 and a positive 6. I hope that makes sense. So this kind of concludes the segment of this video where you can factorize these. Let's look at the ones where you cannot factorize. And at first glance, it's quite hard to determine which ones cannot be factorized and which ones can be factorized. Cannot be factorized. I'm just going to put that small little heading there. So everything after this cannot be factorized. So yeah, my rule on how do you work with them if you cannot tell just by looking at them is just try factorizing it. Just take a moment, a 2-minute moment to factorize it. So if I'm looking at this, I'm looking at factors of 1 that add to give me a negative 3. There are no factors of 1 that add to give me a negative 3. So now just for that 1 second, I can already tell that I cannot factorize this. So instead, I'm going to use my quadratic formula. And if you use your quadratic formula, all you need is this coefficient here, which is your a. In this case, it's equal to 1. You need the second coefficient there, which is your b. In this case, it's equal to a negative 3. And you need this last constant there, which is your c. And in this case, it's equal to 1. And where do you use these guys? Let me just erase this circle here. I was just showing that's where the a is coming from. Where do you use these guys? You use these guys in this formula here. This is called the quadratic formula. And these mathematicians were so smart to actually derive this for us, so we don't need to know how to derive it, but it's a quick way of us being able to solve these equations. All I need to do is substitute there. So what is my b? My b is a negative 3, but there's a negative already, so it's a negative with a negative 3 inside of the brackets. I have a plus minus there. I have the negative 3 squared minus a 4. The a is 1 and the c is a 1 as well. And if you divide all of these with the 2a, and I'm just going to write, for this one, I might, let me plug it into the calculator and just show you how this conceptually looks in your calculator. And then for the next ones, I'm not going to be plugging it into a calculator. I will just assume you can do it, and I'll leave it to you guys. So there's my negative 3 for the b. I'm going to use a plus for now. Square root negative 3 squared minus 4 in brackets 1 for the a, 1 for the c, all divided by 2, 1. And so the first value is a 2.62. First value of x is equal to 2.62. The other value of x is, you just need to go back into your equation, and wherever you had a plus here next to the root, you change it into a minus, and the other value is a 0.38. So this x is equal to 0.38. And there we go. And there we go. So just a side note. These only, so whenever you get a quadratic that you cannot factorize, what type of x values are you getting? These are called irrational solutions. They're not rational. They're irrational. So what does that mean? It means this number that comes out of here, the decimals of that number is not terminating. That means it's not stopping. That means if you're trying to write them, you would write all those decimals and you would actually never finish. It's like pi. Pi is an irrational number. It has unlimited, or rather infinite, decimal points. And so this is the same logic here. So we always just round them off to 2 decimal places because, yeah, we cannot literally write those as a fraction or as something that we can work with, right? So number 2 of these ones that cannot be factorized is a negative 5x squared minus 2x plus 1. So again, what do we need here? We need to know that our a is this guy here. Remember our standard form looks like this. Sorry. Our standard form looks like this. So whatever is multiplying the x squared is the a. Whatever is multiplying the x is the b. And whatever is standing by itself as a constant there is the c. So my a, my b, and my c are all there. So what I will do is I will use my quadratic equation. I show the formula first every single time. And then I substitute into that same formula. I show it on my page so that my examiner can see exactly what I'm doing. Right? With the negative 5 there, with the positive 1 there. All of this is divided by 2, negative 5. Then I plug it into my calculator and I get my 2 values. In this case, you're going to get negative 0.69 as one of the values, and the other one you're getting a 0.28. So you're welcome to try that yourself in your calculator and see if you're getting those 2 values. Right, then let's do another one that is also slightly harder from these 2 that we've looked at already, but also cannot be factorized. Again, in this case, you definitely going to need to multiply across in that bracket to get rid of that bracket. So 4, remember, tells us x times x squared, x times 4, a positive 4x, negative 2x, negative 2x, and lastly negative 2, then positive 4 is a negative 8. And then you get that, and then once you collect your like terms, 4 minus 2 is a positive 2x minus 8, and the 7 is going to join, making it a negative 7. So I end up getting x squared plus 2x minus 15. And then I get something like that. Ooh, I forgot to mention, actually this is quite easy. This you can factorize it yourself. Factors of 15 that actually give you a positive 2. That is quite easily a positive 5 and a negative 3. So those are your brackets. Sorry, I did say this cannot be factorized. I think I lied, because that's just one of your solution, and this is your other solution, which gives you a 3 there, and this one gives you a negative 5. And there we go. At this point, you should kind of see the logic of all of this. Let's take one more really difficult one where you need to really do a little bit of crazy expanding there. Let's look at this. X plus 1 with a minus x, x minus 2, all equal to negative 2, x minus 1. So again, if you're watching this and you're at home and you have your book out and you're actually working through these with me, then I implore you to solve this. The values of x that you should be getting at the end are x is equal to 0.54, that's one of them, and that x is equal to negative 5.54. So try it, see if you're getting it. If you're not, you can wait until the end of me finishing the solution. All right, so I'm going to distribute, I'm going to FOIL those brackets out, not distribute, FOIL. So x times 2x times x is a 2x squared. You times it with the 1, you get a 2x. Negative 1 times x times a 1 is a negative x minus a 1. This is gonna distribute, right? Giving me, maybe let me use another color for the distribution. X and x is a negative x squared. And the next one, negative x with a positive 2 is a positive 2x. And then again, this will distribute into this bracket, giving me a negative 2x with a positive 2. So that's what I'm getting straight from the distribution and the foiling and stuff, right? Then this and this are like terms, right? They subtract to give me just x squared. This minus this plus this, so it gives me a positive 3x, because that minus that is a 1, plus that gives me a 3. So positive 3x plus a 2 would give me a positive 5x. Again, follow there. I'm doing a 2 minus a 1 plus a 2, that should give you a 3. And then you are adding another 2, that should give you a 5. Then lastly, you have this 1 here, minus 1, with this 2 there, which gives you a minus 3, if you bring them all in one side. Then you have this, and your A is 1, your B is 5, and your C is negative 3. Right? I'm gonna substitute them into my quadratic. I'm gonna first write the formula. I don't get marks for this, but what happens in your brain is if you do one thing for a long time, or if you keep repeating the same thing, then it becomes second nature, right? So this formula here will become second nature if you keep rewriting it every single time you're using it. That's how I still remember it from high school, and that's how you will remember it forever as well, right? So once you substitute it, I did say the first x value is a negative 5.54. The other x value is 0.54. So there's one, and there's my second one. All right, so at this point, this concludes the first part of this lesson, which was just trying to solve these quadratic equations, the ones where you can factorize them, and then we looked at the ones where you cannot factorize them. So at this point, you can take a break, pause the video if you want to, go grab a glass of water if you need to, and let's move on to quadratic simultaneous equations. So I gave it this name because you will see that simultaneous equations, you will see that we will be getting two x values. And with those two x values, there will be two corresponding y values. So essentially, this guy has 5 values that we need to solve for. 2 for y, Did I say 5? I meant 4. 2 for y and 2 for x. So those are the x values we should be solving for. Let's take the first example, a very easy one. Like a y is equal to an x plus 2 and x plus an xy is equal to a 4. So as soon as you get these, it's quite nice to always label them as equation 1 and equation 2. So equation 1 is already put so nicely for me in terms of y. I don't need to do anything. So what I'm going to do is I'm going to substitute equation 1 into equation 2. So what I like doing is I write it out like that so that my examiner can see exactly what I'm doing. So I'm substituting equation 1 into equation 2. So if I see x in equation 2, that's where I'm going to put brackets. No, wherever I see y in equation 2, that's where I'm going to put brackets, and I'm going to put in the value of y that I took from equation 1. So that's how it looks. So all I just did was take this equation here, and wherever I saw y, I replaced it with this expression of y that came from equation 1. Then at this point, I don't have any y's in my equation. I just need to solve for x. So let's do that. I'm going to keep this, and I'm going to distribute the second x, giving me an x squared plus a 2x is equal to 4. I'm going to gather everything on one side. This and that will give me a 3x, and if the 4 comes over, it's a negative 4. Then I have this expression. Then this is a quadratic, very easy one that I can factorize. Factors of negative 4. It is very important that you do know how to factorize, guys. The quadratic formula is a very useful tool, but it shouldn't be the one thing that you know. It should be something that you use if you cannot factorize. But again, know how to factorize, guys. Know how to do a trinomial, know how to do a difference of two squares, know how to do a common factor, know how to do all these types of factorization that you should have learned in class 10, in grade 10. All right, so again, going back to this video, factors of negative 4 that add to give me a 3 is a positive 4 there and a negative 1. So what does this give me? It gives me that x is negative 4 for this guy, and that x is a positive 1 for this guy. So all I did was just kind of skip a couple of steps there, but you guys can see where the negative comes from and the positive comes from, right? So I have these x values. What I need to do is I need to take these x values, and where am I substituting them? I'm going to substitute them right here in this equation 1 that I have there. And why am I using equation 1? Because equation 1 is already in terms of y. So it says y is equal to x plus a 2. So I'm going to sub x is equal to negative 4 first. And what do I get? Y minus 4 plus 2, this gives me a negative 2. So for this corresponding x value, this is the corresponding y value that I get. Let me do the same thing, but for the next x value. So I'm going to substitute 1, and this is what I get, 3. And what did I substitute? I substituted x is equal to 1, right? And then if you wanted to put them as coordinates, you can if you want to. So the first coordinate of this guy is a negative 4, as the x is corresponding with the negative 2 for the y. The next coordinate of this guy is that a positive 1 for the x. There's it there. is corresponding with the positive 3 for the y. So that's how you would represent it as coordinates, or you could just, yeah, have them as x is equal to and y is equal to, right? I hope that makes sense. Let's move on to the next one. Number 2. So number 2 looks just like this. I think I'm gonna do a total of 5 for these. And I think at that point you should see what's happening. So number 2, we have this, and we have a y minus an x is equal to a 3. Again, I'm going to call this equation 1. I'm going to call this equation 2. So how does that help us? If you look at the equation 2, there's always going to be one of the equations that are a little bit simpler to work with than the other one. So this is quite complicated. So I'd rather work with equation 2. So in equation 2, I'm going to take it. I'm going to say using equation 2, using 2, y minus x is equal to 3. I'm going to make an equation 3 where I take the x over and I make y the subject. So now I have y as the subject. I'm going to call this equation 3. What am I going to do with that equation 3? Let me write it this side. I'm going to sub 3 into, I have to sub it into equation 1. Why can't I do equation 2? Because I just took equation 2 and I made equation 3 with equation 2. So it wouldn't make sense for me to substitute it back into there. Everything would cancel and I'll just get 0 equals to 0. So instead, I'm going to substitute into equation 1. So if you do so, you have an x squared plus, remember we're substituting for y, equal to a 5. Expand this. So quick way of doing that is you square the first guy, you get a 9. You square the second guy, you get an x squared. You times them together, you'll get a 3x, because 3 times an x is a 3x. And then once you've times them together, you times it by 2, you double it. So 3x plus times 2 is a 6x. That's a quick way of getting rid of those brackets using FOIL. It's basically FOIL, but a quicker way of getting there, right? This and that is a 2x squared. This kind of stays as a 6x, and the 9 minus a 5 will give me a positive 4. I get this. I can divide by 2 on every single one. So if I divide by 2, I end up getting this 3x plus 2 is equal to 0. Essentially what I did was, to simplify this expression, I just divided everything by 2. Then now that you've gotten this guy, you could just easily simplify it. Sorry, not simplify, factorize it. X plus 2 factors of 2 that add to give you 3. Those are the factors, and so x is equal to negative 2, and that x is equal to negative 1. So those are the two x values. Now let me find the corresponding y values. So for x is equal to a negative 2, what am I getting for y? 3 minus 2 is a 1. So I'm getting a 1 for that guy. And for x equal to negative 1, what am I getting for y? I'm getting a 3 minus 1, which is a 2. So these are the 4 values that I was looking for. And there we go. So let's try another one. All right, let's do this third question. So here we're given our equation 1, which looks like that, and our equation 2, which is something a little bit more extensive. But we do not fear. We are ready to take it on. So what we're going to do is we're going to take equation 1. So using equation 1, I'm going to make equation 3 with it. So I'm going to take the 2x over, and I'm going to have equation 3. So I call this equation 3. And that's the one I'm going to be substituting for y in equation 2 there. So wherever I see y, I'm going to substitute that expression there. So it's quite going to be long. So let's see how it looks like. So I'm going to have a 1 minus 2x squared minus a 2, 1 minus 2x minus a 3x is equal to 3x 1 minus 2x minus 1 minus a 2x squared. Make sure you've substituted correctly. You do get a mark just for this step, the substitution part. Then you expand. Remember how I told you how to expand this? I'll say it one more time. And it's a very important skill to learn, especially with these, because it kind of speeds it up. You square the first term, I'll get a 1. You square the second term. So if you square negative 2x, you get a positive 4x squared. So I squared the second term. Then I times them together. A 1 times a negative 2x will give me a negative 2x. Then I times it by 2. So I'll get a negative 4x as the FOIL of that guy. Then this negative 2 would distribute into that bracket, giving me a negative 2 plus a 4x. And this is a minus 3x. And then this will also distribute into that bracket, giving me a 3x minus a 6x squared minus 1 minus 2x squared. Right, so now I just need to collect my like terms. This is a 4x squared, this is a 6x squared, and this is a 2x squared. So 4 plus a 6 plus a 2 would give me a 14x. Not 14, sorry. Let me try it again. 4 plus a 6 will give me a 10, plus a 2 is a 12. So it's a 12x squared. Right? Let me do the x's. This and that are going to cancel, so I'm just left with the negative 3 there. Negative 3x minus another 3 will give me a negative 6x. Right? And then lastly, I have the constants. 1 minus 2 plus 1 would give me a 0. So this is essentially left like that. Then once you have it like that, at this point, only thing you can do is to factorize it by taking out a common factor. So I take out 6x is my common factor. I'm left with the 2x and a minus 1 there. Right? This is equal to 0, which makes x equal to 0. Or 2x minus 1 is equal to 0, which makes 2x equal to 1, which makes x equal to a half. Alright, so please do not forget, guys, you've just solved for x now. We need to go back into that very easy equation, this equation 3, and solve for y. So let me write my equation 3 here. There's my equation 3. Let me solve for y underneath the corresponding x. So I'm going to substitute the 0, and this y will be a 1. And for this one, I'm going to substitute, 1 minus 2 with a half in brackets, and that will give me a 0 for y. And there we go. So these are my corresponding values. This x goes with this y. If you want it as a coordinate, there it goes. And this x goes with this y. If you wanted that as a coordinate, it looks like that. Hope that makes sense. Let's look at one where, I don't know, it's not as clear cut as these. If we scroll up, let's just take a moment. If we scroll up, you will see that in each of these, you just needed to do just a slight little bit of work to get equation 3. And it never came out as a fraction. So either the y had a coefficient of 1 or the x had a coefficient of 1, where you could just easily do it, you know. But let's look at one where you can't just easily get equation 3, or you can get equation 3, but equation 3 looks messy. It looks like a fraction. And I know the stigma around fractions in mathematics, the fear that you guys have against them. And yeah, the more you work with fraction, the more you kind of get rid of the stigma, and the more you kind of get rid of the fear. So it's like facing your fears. So this is one of those fraction ones. This is equation 1, and this is equation 2. So if I take equation 1 again, using equation 1, I'm going to get 4y minus 3x is a 4. I'm going to make y the subject, so it's a 4y is equal to a 4 plus a 3x. And then I would need to divide by 4 in both sides. Yes. And if you divide by 4 on both sides, you end up getting that y is equal to 4 plus 3x over 4. That's your equation 3. So you're looking at that equation 3 and you're like, Mr. Malaji, how are we going to substitute that? We can, guys. We can do anything we set our minds to. So there's my equation 2. And wherever I see y, I'm going to put this fraction in there. And I'm going to square it, minus 2, 4 plus 3x over 4. And this is all equal to 24. So there we go. We've substituted correctly, right? Now let's expand it. So I'm going to keep this x squared. And here, if you're squaring the top and you're squaring the bottom. The bottom is quite easy. You're squaring a 4, you're getting a 16. The top is that same method. Square the first guy, get a 16. Right? Let me just make this a little bit longer. Square the second guy, get a 9x squared. Times them together, you get a 12x. And times it by 2, so you get a 24x. And there we go. Then this negative 2 times into this bracket will just cross cancel with this 4 there. So you end up with a negative 4 plus 3x over 2, all equal to 24. I hope that looks good to you guys, right? And then at this point, I need to get rid of the fraction. So what I notice is that the LCD in this equation is actually 16. So we'll talk more about LCDs and what those are once we do the fraction segment of equations. That's going to be in another video. But in this case, our LCD is the 16. And how do I know? Because the 2 can divide into the 16. So if the smaller one can go into the bigger one, the bigger number will be our LCD. What do we do with that LCD? We times every single thing with that LCD. How does that look? This x squared times LCD is going to be a 16x squared. This fraction times the LCD will just be the numerator, because it's going to cancel with the denominator, obviously. And then the second fraction times LCD, you'll end up getting a negative 8. And then bracket, and then you need to times this negative 8 into the brackets. How am I getting negative 8? Because if I'm timesing a 1 over 2 times a 16, these cross cancels and they give me an 8. And that 8 needs to multiply this numerator. I hope it makes sense, but if it doesn't, if it does not make sense, that's okay. That's really okay. You just need to tune into the next video because, yeah, I'm going to have more time to explain it in that video. All right, so let's just finish this. I'm trying to keep this all under an hour. So we have what? X squared there, but we have this negative 8 that we need to distribute first. Let's do that. But the 16 and this are going to give me a 25x squared. The 16, there's nothing you can go with, so just keep the 16 and bring the minus 24 from the other side. We still have this 24x that comes from here, and this negative 8 is going to distribute, giving me a negative 32, negative 24x, all equal to 0. I keep this, doesn't have a like term. The 24 and this guy are both going to cancel, giving me just 0. And then 16 minus 24 minus 32 would give me, what does that give me? That ends up giving me, I forgot something. Did I times the 24 with the 16? I forgot to times the 24 with the 16, sorry. When I was timesing LCD with everything, I forgot to times the 24 with the LCD. That also needs to be multiplied by LCD. So if you multiply it with LCD, it's a 384. So when you're bringing it over, in this case, this will be the 384. So we have 16 minus 384 minus 32, and that will give you a minus 400, right? Sorry, my bad there, slight mistake. I forgot to times the right hand side with the 16. All right, now we have this. I'm taking our 25 as my common factor, x squared minus, that will be 16. Then I could divide both sides with that 25, it just goes away. So I have negative x minus 16 is equal to 0. That is just a difference of 2 squares. X minus 4 in one bracket, x plus 4 in one bracket. I've already talked about how do you do those difference of 2 squares. So x is equal to 4 there, and x is equal to negative 4 there. These are the two x values. Again, I go back to equation 3 that you see up here to solve for the y. So y will be equal to a 4 plus a 3 for the first x value, the 4 one. And if I just quickly plug this into my calculator, I get a positive 4 for y. Then if I do it for the second guy, 4 plus a 3, negative 4 in brackets, all divided by 4, and if I plug this guy in, I get a negative 2. So what are these values that I'm getting? I'm getting a y is equal to 4 for these values that are corresponding. Let me just write it quite neatly. Y is a 4 for this ones, and for this one, y is a negative 2. As a coordinate, that one looks like this, and as a coordinate, this one looks like that. So I'm putting it as a coordinate now because I already want you thinking about what does simultaneous equations look like on the graph? What does that look like? What are these coordinates, and what do they tell me? All right. At this point, take a breath. We have 10 more minutes. And in this 10 minutes, I think it's enough for me to finish the last question. But take a breath, get up, stretch your legs, make sure you are wide awake for this last part. And in this last part, we have something that looks like that. Remember you guys did, what do you call this? Exponential equations? So yeah, this is a mixture of quadratic equations that have exponential equations that are also simultaneous equations. So this is quite a mammoth of a question, but it's not really that crazy. What we need to first do is take equation 1 and work with it for a bit. Rearrange it for a bit. What do I mean? So these are bases of 2 that are multiplying. And what do we do with that? We add the exponents. So I'm going to add the exponent on that side. The 8, I'm going to change it to be a base of 2. If it's a base of 2 to the power of 3 gives me an 8. So I end up getting this guy. And this guy, you could just easily make these exponents equal to each other. So it actually simplifies to give me this guy. And in this guy, I could just easily make x the subject, 3 minus y, and call this equation 3. Where am I going to use this equation 3? Let's substitute it into equation 2. So sub 3 into 2. So sometimes I write this, sometimes I forget to write it, but yeah, I think you should get into the habit of always writing it, just so your examiner knows exactly what you're doing and you're communicating to your examiner. Remember, math is you communicating this language to your examiner. So if your examiner does not know exactly what you're saying, does not know what you're getting at, then how are they going to give you the necessary marks for it? So make sure your examiner knows exactly what you're doing. All right, let's substitute. So if I see x, I'm going to put in brackets, I'm going to put a 3 minus y squared. I still have my y squared, and all of this is equal to 5. Again, square the first term, square the second term, times them together, and times them by 2. You get that guy. Get into the habit of doing it, guys. It's so nice how you can expand that without actually writing it out as FOIL. So this and that gives me a 2y squared. I have my negative 6y there, and a 9 minus a 5 is a plus 4. So this is divisible by 2. Divide everything by 2. Taking out a 2 and then cancelling it later on, or dividing everything by 2 is the same thing. So I'm just going to use this one because it's quicker. And then now I can factorize it. Factors of 2 that add to give me a negative 3 are these. Negative 2 and a negative 1. And once you solve these, y is a positive 1 and y is a positive 2. But remember, we are not done. We still need to find what x is. And so substitute where y is 2, and let's see what x you're getting. 3 minus 2, x is equal to 1. So there's my x and there's my y. And for the next one, 3 minus, wait, let me write the y first. Where y is 1, I'm getting an x is equal to 3 minus 1. And so x is a positive 2. And there we go. If you wanted to write these as coordinates, this is a 2 and a 1. Sorry, not a 2 and a 1. X first, 1 and a 2. And this is a 2 and a 1. And there we go. This and this. And we're done. All right. Thank you so much for tuning in. This video just literally just goes through quadratic equations and quadratic simultaneous equations. And what I really need you to get from this is how to solve these different types, but also the tricks and tips, and you know, how do you expand a bracket that has a binomial there very quickly. So those tips and tricks, that's what I want you to take most out of this video. Yes, obviously how to solve these, but the tips and tricks that really came out of this video. So on that note, I will see you in the next video. Goodbye, and yep.